Of the Hexalectris colemanii in southeastern Arizona. I'll start with an explanation of what a Hexalectris is, the species status of the orchid, and the geographic problem, and then talk about my methods, including the survey data, examining the canyon details where the orchids were found, and potential terrain impacts. For my analysis, I did a multivariate logistic regression and probability modeling, and after that I'll go through some of the model efficiency. So this is my project area. It's approximately 18,000 square miles. For the purpose of this project, I kept everything to Arizona, even though the orchid does exist just slightly over into the New Mexico border. Hexalectris colemanii, or Coleman's coral root, is found in the Sky Islands of southeastern Arizona. It's in canyons with seasonal water. It does not bloom every year. It's very irregular. Lives almost exclusively underground and is associated with mixed oak woodlands. In fact, it gets its nutrition from a fungus found on the roots of oaks. It's previously been known only up to 5,200 feet, but as of 2013, we did find some a little higher, so that's moved to 5,620. Prior to 2010 and in 2010, there were only 4 canyons where the orchids were found. On this map, you'll see colemanii and species. If the only way to positively identify the orchid is if it's flowering. Otherwise, if it's just the stalk, it's listed as a species in the map. As of 2013, with subsequent surveys, you can see that it's been found in far more. So the question is the species status. Colemanii was a subspecies originally of Hexalectris revolute, and in 2007 it was petitioned for federal listing. As of 2009, the Fish and Wildlife Service considered it warranted, but no decision was made. In 2010, it was considered a separate species, and shortly after there, it was petitioned for federal listing by the Center for Biological Diversity, and that's currently under review. So the geographic problem is that Hexalectris is very difficult to find. It's spread out over large geographic areas, and it flowers just between like mid-May to mid-June. As I said before, the populations can't really be identified unless it's flowering, so it's a limited time and a large amount of area to cover. So although they are limited to oak and between certain elevations, the terrain seems to be varied, especially with the additional data taken from 2010 to 2013. And without a better understanding of its rarity, it'll be difficult for a federal ruling of endangered species. So establishing correlations or negating them between orchid habitat and local terrain could potentially be helpful in locating orchid populations, which may accelerate a decision regarding the endangered species listing. For the survey data that I used, most of it was done by Westland Resources. Some orchids were found in 2010 by M. Baker, and prior to 2010, the 4 canyons that were located were by Coleman. That's who the orchid's named after. For the most part, GPS units and GPS cameras were used in the field. In some cases, the data was added manually. In 2010, I had large polygon areas instead of tracks, but in 2011, about half I had GPS tracks, and in 2013, I had tracks for almost all the canyons. So I buffered all the tracks out to 30 feet, and the reason I went with that is after talking to the biologists, they usually walked about 10 feet apart next to each other, and they could see for about 10 feet on either side. So I merged all those tracks after I cleaned them. Sometimes they forgot to turn off the tracks and drove off. And so I cleaned those and then merged them with the larger polygon survey area. And then as far as the points for where the orchids are actually located, most of them were georeferenced photos, which I imported and made into points. So the green's a little bit hard to see, I realize, but those are the survey areas that were actually walked and looked for orchids. And then there's just one dot for each canyon located for the species and the colemanii. The next series of slides I'm going to go through fairly quickly. They're canyon details, but what I want to focus on is the varied terrain. Like you can see here, it's fairly wooded and fairly close to water. Here we've got a large group of them, but further off the water and a little more elevation change. Once again, this is a little denser area, and yet the area around it is pretty bare. Heavier wooded and steeper canyon. The two species on top look like a pretty different area than the two found further down. Once again, large cuts in elevation. You can see here that there's not much vegetation in this one. Once again, very steep terrain here. A lot of heavy vegetation. You can also see they come grouped or in ones and twos. This is the only canyon they've been found in New Mexico. So in order to do the model, I looked at potential terrain impacts to see if any of them might have anything to do with where these orchids are growing. I looked at aspect, front and low vegetation, elevation, landform, maximum elevation, distance to oak, average rainfall, slope, relief above target, shelter exposure, distance to streams, texture, total relief, and all-risk vegetation. Different tools were used to make all of these rasters. But in general, it was either focal statistics, Euclidean distance, or polygon to raster. So for the multivariate logistic regression, created a representative sample of random points within the survey area. We determined, we being Tom was helping me with this one, but 1,068, we used about a 6-inch area for each orchid and then did square inches for the entire survey area, plugged that into the calculator, and they told us this would be a representative sample. So after the random points and the orchid points were established, we used the sample tool to create a table for all variables. And theoretically, this can be done all at one time. It did not work for me that way. I had to do each table separately, then joined the tables, exported it, and then cleaned out the redundant data. So ultimately ended up with two tables, one for the random and one for the known points with all the variables attached. I then added a field to each one, putting a 1 in the orchid data and a 0 in the random points created. And then those two tables I used append to combine them and export it into a database. So from the database I used SPSS, IBM software statistical package. The dependent was the sample field I created, both the 1s and the 0s, and the covariates were all the variations of the rasters. The first regression didn't come out overly well. For it to be statistically significant, it needs to be less than 5% in the significance column. So you can see that I cleaned out quite a bit of those data. I reran SPS with only those variables, and those were elevation, average rainfall, slope, distance to streams, aspect, and shelter. After that was run, I corrected the constant because we had different numbers in the sample and in the random. And for the first model, I used raster calculator with the regression results to create a model. So that's basically the formula I put into the raster calculator, but it's the weighted variables and the corrected constant summed with everything. And that is the first regression model. You can see I've got a high of 69 and a low of -38. So for the probability model, I needed to put my values between 1 and 0. So you can see where I started, and then with that equation, got it down to 1 and approximately 0. And that is the probability model. So I took the probability model at that point and made a bin model, and that's basically taking anything above 0.5 and calling it potential habitat, and anything below, not so much, which looks very similar to the other one. You can see at this point I'm starting to get like large areas of green, which is the greater probability. So then we move into the model efficiency, and for that we need to determine the percentage of project area in areas most likely to contain orchids with the con statement, and then determine how many sites fall in the most likely area using a sample to create a table. So this, I realize is kind of difficult to see, but it's the model just within the survey areas. And the efficiency calculation is efficiency equals 1 minus the total area within the most likely area divided by the percent of total sites within the most likely area, and it came out to 17%. So obviously 17% wasn't what I was hoping for, but overall it does tell us something. Although several of the terrain aspects had statistical significance, overall they probably aren't a leading indicator, at least these aren't, of where we can find the orchids. I did use a 30-meter DEM, and it is possible with a better resolution DEM that might change slightly, but overall I would say that it's not a great predictive factor, and further examination can take place in other areas. Any questions?